Welcome to Switzerland Innovation Park Zurich. Behind this building, 12 students worked the last 12 months on a very interesting project in future or for future aviation.
Exactly. They have developed the world's first electric four-seater aircraft, the so-called e-Sling, and today is the rollout event, and we'll talk with some interesting people that have been heavily involved in the project.
So very happy to share with you all this information and give you a glimpse into this future of aviation. Next to me is Nicolai, one of the co-founder of the e-Sling project. So maybe you can just give me a short intro about yourself.
Well, I'm a mechanical engineer. I was doing my bachelor thesis as a research project, whether it's feasible to have an electric aircraft. And at that time we realized actually it is possible meanwhile to have an electric aircraft. And that's the reason in 2019 we decided that we want to go on with this project and finally realize the project. Yeah.
And what do you have in common with electric mobility and aviation?
So our institute has this expertise in electric drivetrain. So we have developed already electric motorcycles or cars. And then once in 2018 a colleague came to the head of the institute and asked, why aren't you building an electric aircraft once? And that's basically where e-Sling was born.
Cool. And when was this?
Well, born it was in Christmas 2018.
2018. And when did you?
2018.
2018. And when did you actually start with the project?
Well, that's actually crazy because the project was started with 12 students exactly 1 year ago. So in 12 months, these 12 students, they have developed the complete interior of the aircraft.
And no one from the students came from aviation before, or?
They're all second class or second year students at mechanical and electrical engineering department. Yeah.
Great, very interesting, and congratulations again for this project. Very nice to see now here. I just can imagine you showed some picture before where we have seen the hangar without anything in it, and now we have a fully equipped production line, so on. It's crazy what was all behind, and just 12 people. I guess also a lot of supporters.
Indeed, basically we started 1 year ago with basically an empty hangar.
Okay.
And it's already a project having the equipment of a complete hangar, of a workspace. And the students managed to get equipped a complete hangar, but also to develop the electric aircraft.
How much money you needed for all this? For the hangar and the aircraft and...
Well, it's a lot. It's a lot.
So, any numbers around?
I cannot
1
give
million,
a number.
10 million?
No, it's not 10. No, it's not 10 million. No.
But
it's below.
It's close
around
to...
close to 1 million,
okay.
Probably. Yeah.
How many supporters you had behind this?
So we have 6 founder members that we have developed the project since the beginning. And meanwhile, we have the 12 students who are working full-time for this project. There is approximately 10 freelancers who are working for free, voluntarily on the project. They're doing some parts. Additionally, just a week ago, we started with a new project. Another 8 students coming and started their own project.
Okay, and you will be part also in future of this project? Or?
Yeah, for sure. We will coach and continue the coaching of this student project. Yeah.
And it will be something like hydrogen aircraft?
Exactly.
Or?
The next project will be a hydrogen aircraft, and that's where we are now putting our focus on. Of course, on one hand, getting the aircraft into certification, into the air.
Yeah.
And on the other hand, also developing the next electric drivetrain based on hydrogen.
So it will be also with a sling, or it will be completely a new project with a new aircraft?
It will be a completely new project.
Okay, cool. So thank you very much for this information.
Thanks, you too.
And good luck with all other projects coming up.
Thanks.
Thank you.
All right, goodbye.
Thank you, bye. Next to me is Anna. She was or still is one of the 12 project students behind the e-Sling. Congratulations, first of all, of this very nice aircraft.
Thank you.
Just can imagine a very great feeling for you seeing it now completely settled. Why aviation? Why electric mobility? And Anna, what's the connection between?
So yes, I have a huge fascination for electric drivetrains. And then I wanted to really do research in becoming and finding a sustainable solution for the aviation industry. And that's how I combined these two.
Any background from your family with aviation, or?
No, actually, absolutely not.
Very new in this business. Okay.
Yes.
Cool. So I guess you're the expert seeing here the technology behind. Maybe you can just explain from the propeller back to the battery what's going on here, what we are seeing here.
Yes, sure. So yeah, here we have our propeller, which is powered by our electric motor. Here we did the thermodynamic analysis and also the mounting, and our partner ENA did the electromagnetic side of it. And it is air-cooled, as one can see by these cooling ribs. Then right behind it is the inverter. That's where I worked on in a team of other 3 students. And the inverter, it transforms direct current from the batteries into a 3-phase alternating current for the motor, and thereby actually taking into account an entire motor control cycle. So we have a look at the current and then see what kind of a torque do we actually want.
And any numbers behind the inverter?
So, well, motor and inverter together, they have a takeoff power of 110 kilowatt. And in the inverter, for example, we have a switching frequency of 15 kilohertz, which is quite high. Thereby we used a silicon carbide technology.
Cool. And then it's going to the battery. So
exactly.
It's a very small battery package. Is this enough for, or what is the range of the aircraft?
So first of all, so yeah, here, that's the inverter down there. Then we have the high voltage power distribution unit. And then this is one of only 3 battery packages.
Okay.
So this is the smallest, which is still in the motor compartment. But the main actual battery packages, they are in the wings.
Okay.
So here you
like
can see
the fuel in a normal Sling.
Exactly. No, this is where the fuel tanks would normally be.
Okay.
And we replaced them with battery tank.
What's the size of it? I just can see here some screws around it. So it's only
up to there.
This side.
That's filled up with batteries. Exactly.
And
the cooling system is there as well.
So the engine is cooled via air.
Yes.
And the battery is cooled with a liquid system.
Exactly. As you said, motor inverter is cooled directly by air, and then we have a cooling system which is made up of water glycol. And here there are pumps that run through them. So it's always a battery package, and then we have a cooling plate in between where this cooling liquid can go through.
Cool. What's next?
What's next? So the final tests are still going to happen. We've already successfully validated the entire powertrain from batteries to up to motor and in propeller, and they were successful, so that was good. But now the final tests we will run flight cycles. Of 3 minutes of giving full power, and then 14 minutes of giving climb power, and these are still
I guess this will be the next emotional moment for the team.
Definitely.
Seeing the aircraft flying at the first time.
That comes, of course, afterwards. We have this certification process, and then we are aiming for a permit of flight.
Cool. And what for you next?
For me,
a big break maybe.
Yes.
After a lot of night shifts.
Exactly. Looking forward to that. But also, I'll still be working with the project a little bit, helping the new students. Yeah. We have a new generation of students taking over.
Okay.
And just for the beginning, I will be here and also showing them the powertrain. But then they will take over, and they're also focusing on a powertrain driven by hydrogen. So they're also working on that and getting the plane into air. These 2 things.
But for you, this project is then in the next few months finished?
Yes. For me, I will finish my bachelor's at ETH, and with that, I'll also kind of finish a little bit with the project. And afterwards, I will probably start with my master's or do an internship somewhere.
Cool.
Yes.
So congratulations again.
Thanks a lot.
Very nice. Thank you also for all this information.
Sure.
And good luck for you for the next journey.
Thank you.
Cool. Thank you. So Anna told us a little bit about the battery. Next to me is the battery expert of this project, Mischa. Yes. Also to you, congratulations. Very
Thank
nice
you very
project.
much.
Very nice to see now the aircraft together. And yes, maybe a short intro also from you. Why aviation? Why electric mobility?
So, I mean, electric cars, you now see them everywhere on the streets. And like electric aviation, it's slowly coming, but it's a huge challenge, especially the batteries, because they're heavy, they don't store that much energy as like normal fuels. So I saw that they wrote that they want to build electric airplane, and I thought I can't miss out on such a great opportunity to be part of something this innovative and also challenging. It definitely was a challenge. Yeah.
I could imagine, but now very nice to have this project in the CV, building up an aircraft from the scratch. So tell us all about the battery behind it, because I think it's just the most difficult part in this project.
Yeah. Yeah, so I mean, batteries generally, the weight is a huge problem. I mean, fuel is normally 100 liters in an airplane, and we have to replace that with batteries. So we have to try to get as much energy in the same weight. And batteries have about 10 times less energy than fuel. So our challenge was to get as much energy into a wing or into the battery box as possible. That's why you can also see the battery shape is formed like the leading edge of the wing, because we try to get as much volume out of the space we had.
So there was no existing battery package just to put in the aircraft? So
No. So there's no commercial available battery that's made for this kind of applications. And we knew there was a huge potential to increase energy density in batteries, especially now for aviation. That's why we chose only to buy the cells and to make everything else ourselves, or partner up with other companies. Exactly. And here you can see the result. So it's a quite weird shape. Two modules on both sides that are pressed onto a cooling plate. The cooling is very important because the lifespan of a battery decreases the warmer you operate it. So the cooler you can keep it, the better. And batteries generally only are allowed to get up to 60 degrees warm. So if the outside temperature is 30 degrees, you only have 30 degrees Celsius to cool it down. That's why we chose to go with fluid cooling, like in a car where you also pump water through it. Generally, lots of people are afraid of water and batteries together, but if you do it correctly, it's no problem. And this way we can guarantee that the batteries stay cool during flight, so we can also have a big safety margin and not have to land in case it's slightly too warm.
Okay, so we are talking about the battery package of how many kilowatt hours?
So in total we have 50 kilowatt hours divided up in 3 batteries, and each battery is independent from each other. So we can fly on one battery alone, as long as it's not the motor compartment battery. That one's too small to keep up the cruise power, but the wing battery can give up to 66 kilowatts. That's enough to even slightly climb. Okay. So in case we have a failure in 2 batteries, we can still continue flying, which helps for certification, because then we don't have to be worried about just having to emergency land in case one battery gets too warm.
And always the biggest questions in e-mobility, what's the range?
So yeah, in airplanes that's a bit more difficult, because if you have headwind, you're going to go way less far.
So let's talk about endurance then.
Exactly, yeah. So if you totally deplete the battery, we expect 1.5 hour flight time. Now, of course, you don't want to do that. You generally want to use it between 80% and 20%. So that would be around 1 hour flight time that we can expect. And generally, we also need a half an hour reserve at the end of the flight, which is actually really nice, because then we don't have to deplete the entire battery. So we can use these last 20% as our reserve and use the rest like a normal battery.
Okay.
Exactly.
And always a big question is also charging. So we have here a charging module. How you can charge this aircraft?
Yes, so...
And how fast?
Yeah, so battery specifications give it 1 hour to charge. So we could recharge the entire battery in 1 hour if the charging device can handle the power.
Sure, yeah.
So, but generally you don't want to charge that fast. So we will test it at 3 hours. So that way we prolong the life of the cells, and in the testing phase, it's not that important to have a fast turnaround time.
Yeah, sure.
But if you know the cells enough well, you can also start increasing the charging speed, like by electric cars in the moment, which can charge within 40 minutes or so, which will also be possible with this, especially since our cooling system is really good. We can also extract the heat during charging very well.
So now the aircraft is pretty much ready for the first flight. What are now from today the biggest challenge until the first flight from your part?
Yeah, so now it's really important to show the authorities that it is reliable and is safe. That's why we'll also, after this event, we'll take it out and put it in our test container where we are going to fly or simulated flights.
Okay. And
that way we can after do 20 of these and show them we never had a failure in the battery. We could fly longer than we needed, and the temperatures of the battery never went above 45 degrees.
Okay.
Exactly. So that's one important step to show that the safety is there, everything that we engineered works, and after we can put it into the airplane, do the same tests, not quite as many, and then we can go onto the runway.
Cool. Yeah. And then after this project, what's your next step personally?
So I'll start my master's in 1 year, and in that time I want to still do some internships, and I want to be in this. I want to stay in the battery technology because it's really interesting, and there's tons of advancements in the next couple of years. But I'll definitely still be around e-Sling and help the next couple of generations, helping them get it to fly.
I'm sure you want to see the first flight.
Oh, definitely,
cool.
Yes.
So
definitely.
Congratulations again. Thank you very much for your time.
No problem.
And see you soon.
Bye.
Thank you. Bye. Mischa. Elsa's shirt is white. Why?
So I'm from the new project. Our project is e-Sling Project Hydrogen, and we're the next generation for this project.
So is today for you the first day to start the project, or did you already start?
It's kind of the first day, but we worked on it like the past 2 weeks.
Okay.
For organization and getting to know each other, and yeah.
So there will be now overhanding from the old group to the new group.
Yes.
And you will try to profit as most possible from the old group.
Yes,
so
exactly.
So for you is now the project to continue this one. So certification and all this, and then going to hydrogen electric aircraft.
Exactly.
And this will be also with this aircraft or with a new one?
So our goal is to do it with this one, but I think it's going to be a decision in the future, so we don't know it yet.
And how big is your team?
We're 8 students,
okay.
So 7 mechanical engineers and 1 electrical engineers.
And do you also have to find some sponsors for this, or you can overtake them from the old group?
So some of them I think we can overtake them. But of course, we all need sponsors, so we're looking for them.
Cool. And how long you will be on this project then? Also 12 months, like the others?
Yes, exactly. So 1 year. Like our goal is to give the project to the next generation in 1 year.
Okay. And what do you think will be the advantages of the hydrogen aircraft comparing now with this battery-powered aircraft?
That's the most important question.
Yeah.
I think.
Or what you hope will be the advantages?
Yeah, it's hopes. So I think the most important thing is that the weight is going to be lower, so the aircraft can fly longer distances, and it's more like real traveling with green energy.
Okay. Is there already an aircraft with hydrogen out of the market, or will this be the very first hydrogen aircraft?
I think it's going to be one of the first.
Yes.
It's not a hydrogen aircraft yet on the market, but many different stations are developing one.
Cool. Thank you very much for this information, and I wish you good luck for the hydrogen aircraft. Thank you.
Thanks.
Cool.
Yeah, so we had a nice day. We met some interesting people. We're wondering, let us know if you have any similar projects of universities in your countries. And we are very looking forward to the inaugural flight of this experimental aircraft, and we'll definitely be filming that, and maybe we can smuggle a GoPro on this airplane.
Yes,
and show
maybe
you.
we can smuggle ourselves into the aircraft
Yeah.
to try it once. I really want to try it out.
Yeah, me too.
Because after flying the e-Wheelies, this would be very different because it's an actual aircraft, a little bit more than the e-Wheelies. It's a 4-seater, and I can just imagine to take off here and enjoying the beautiful mountains, which are just 20 minutes away from this airport here in Dübendorf.
So, thank you for coming along. You know the deal. Like and subscribe, and see you on the next one.
See you on the next one.